Okay, again, complex fractions. Fraction divided by fraction. When you divide, well, a fraction divided by a fraction, so we could write that out with a division sign. And of course, division by a fraction is multiplication by its reciprocal. And we get 20/72. Now 20, we would normally look for common factor, biggest common factor, and divide it both into the denominator and the numerator. Sometimes that's impractical because your numbers are just too big. You can't easily find common factors. So you resort to prime factorization, which we used last time. So you divide the 20 by 2, leaving you 10. You divide the 10 by 2, leaving you 5. And we find that 20 is 2 times 2 times 5. Similarly, 72 is 2 times 36. 36 is 2 times 18. 18 is 2 times 9. And 9 is 3 times 3. So now we have 5 over 2 times 3 times 3 times 2 times 2 over 2 times 2. And what we're looking at is we're taking the maximum number of factors from the numerator and denominator that match up. 2 times 2 over 2 times 2 is 1, so this is 5 over 2 times 3 times 3. Of course, that's 18, so that's 5 over 18. Okay, now let's take these two fractions. Okay? They're in symbols. Divide this by this, meaning, well, we write that out as a division. We do it carefully because I did it a minute ago and did 2 steps at once. And wrote it out wrong. Okay? So we have this divided by this, and this is the same as this. Now we're going to do the reciprocal. That's what I did. I did divided by, and then I did the reciprocal. Okay? So don't do what I did. In any case, this gives us x squared plus 6x plus 5 divided by x minus 3 multiplied by x squared minus 9 over x squared minus 4x plus 3. And now I factor this and this and this. This is already factored. So the x squared plus 6x plus 5 is just x plus 5 times x plus 1. That's over the x minus 3. And then I have x minus 3 times x plus 3. That's how we factor the x squared minus 9 divided by x minus 3 times x minus 1. Okay, so now I write out the entire numerator. Now, immediately, I could factor out the 2x minus 3's here. And we might do that. I don't just cross them out. I factor them out, make sure that it works, make sure that these are actually factors. Because cancellation doesn't work if you don't have factors. And people, as I've said many times, there's an epidemic of people factoring things that aren't factors. Okay? Or canceling things that aren't factors. Canceling comes down to factorization. Okay, so we have x plus 5 times x plus 1 times x minus 3 times x plus 3 over x minus 3 times x minus 3 times x minus 1. Now we see that we do have an x minus 3 in common between the numerator and denominator. And I'll factor on this side, x minus 3 over x minus 3. And And then that's gonna be multiplied by whatever's left here, x plus 5 times x plus 1 times x plus 3 over x minus 3 times x minus 1. Now the x minus 3 over x minus 3 divides out, gives us 1. Again, no matter what the value of x, the numerator is going to have the same value as the denominator. So it's going to equal 1. So now this is x plus 5 times x plus 1 times x plus 3 over x minus 3 times x minus 1. There are no remaining common factors. This is your factor form. And the expanded form a little question mark that I'm going to do in my head. Okay, first of all, the denominator is just x squared minus 4x plus 1 plus 3. Okay. Now, that appears to match what we've got here for reasons that are fairly easy to trace. You don't have to. And then x plus 1 times x plus 3 is x squared plus 4x plus 3. Multiplying by x, we're going to get an x cubed. That's going to be a 4x squared. But then we're going to have a 5x squared, so that should be 9x squared. And then x is going to multiply the 3, we get a 3x. And the 5 is going to multiply the 4x, giving us a 20x. And then it's plus 15. Okay, if I did the arithmetic right, that's what this would look like in expanded form. Okay? Again, both valid forms depending on what you're wanting to do with it.